Okay, so moving on. So this is what we've been hinting at for the last couple of sections, this idea of slope. So now we're going to get out the formal definition so we don't have to use the average rate of change. It's a bit of a mouthful. It is good to note, though, that they are essentially the same thing. Average rate of change is kind of when we're talking about application problems. Slope is typically used when we're talking about algebra problems, but they're the same thing. We're talking about the rate of change of the outputs over the inputs. So to write it out formula, if we say we want to find slope, that is equal to, usually the letter that we use is m to define slope. So we typically don't use that very much when we're solving for variables, for the reason that this usually universally stands for slope. So when we see m, your brain should think slope. And again, that is the change in the output over the change in input. This notation is a bit fancy. You probably won't really see it outside of any calculus class or any high-level math courses, but it's Greek. The triangle is delta. That's a Greek letter for delta, delta y over delta x. And when you see delta, that means change. So it means the change in y over the change in x, delta y over delta x. Or if we're looking for just a strict formula, and let's say we have points to find our slope, we would do y2 minus y1 over x2 minus x1. And that's really the valuable thing. The rest of it are kind of just, oh, if you ever see it this way, this is what it means. Really, I want you to understand that m is equal to y2 minus y1, because that's how we are going to go through and solve problems, is by using that formula. So let's do that now. So let's say I have these 2 points, -5, -3, 5, and 3, 17. So for me, it's kind of good to label out the points. So let's actually go ahead and write that. So once you get more comfortable, you could probably go straight to the actual formula. But until you get to that point, I always find it helpful to kind of label what we're looking at. So if I have my point -3, 5, well, that -3 is my x1. This 5 is my y1. This 3 is my x1, or x2, and this 17 is my y2. And if I have those labeled like that, it makes it a lot simpler to, instead of say, okay, where did that go? Where does my 5 go? Where does my 3 go? It's easy to keep everything straight and say, oh, okay, well, my y2 is 17, that goes top left. My y1 is 5, that goes top right. My x2 is 3, bottom left. My x1 is -3, bottom right. Another thing to note is that we have that 3 minus -3. So that's in the formula, and we're going to have to be aware that if you're subtracting it negative, it becomes a positive. So let's pop back into the lecture. So now we just kind of do some algebra behind it. 17 minus 5 is 12. 3 minus -3, again, we're going to flip it. It's going to be 3 plus 3 is 6. 12 divided by 6, if we reduce the fraction, is 2 over 1, or 2. So usually we kind of skip that middle step of saying, oh, 12 over 6 is 2 over 1. The reason I don't want to skip over that in this particular case is because slope is a change in input over change in output. So if we're going to write it shorthand, or if we're kind of writing a formula, it makes sense to write the 2. But I don't want you to lose sight of what that 2 stands for. That 2 stands for the change in output, which will be 2, over the change in input, which is 1. So usually it actually makes a little bit more sense to represent it as that fraction of 2 over 1, but they are the same thing. Certainly algebraically, 2 over 1 is equal to 2. So I'll bring that up again when it kind of becomes important to it in an actual question. Okay. So moving on, we're going to use this idea of slope to actually draw lines. So we have a line, we want it to go through 0, 3, and we want that line to have a slope of 1/2. So if I'm going to draw that line, what I'm going to do is, well, I want to identify, that my slope is, and kind of a common way to remember it is that slope is rise over run, which means that that rise is my change in my output, my run is my change in my input, or my rise is my change in y, my run is my change in x. It's just a quick way to kind of remember it. You don't have to remember it that way. It's very common though when people say, oh, slope is rise over run. That is what they mean. So I'm going to take that point, 0, 3, I'm going to plot it. We've seen plotting before, nothing too fancy. It goes 0 up to 3, plot my point 0. Now is the kind of bit that you may have not seen in a while, or even seen before ever. Rise over run is my slope, so I'm going to start at that point, which is 0, 3. I'm going to go up 1 over 2. So there's that rise and run again. Up 1 over 2. I go up if it's positive, I go to the right if it's positive, and then I plot my point. And then I'm going to do it again. I'm going to plot another point, up 1 over 3. Sorry, up 1 over 2. Those are my points. That's all I need to have. We talked about in a previous section that you only need 3 points to draw your line, and voila, there is my line that is through 0, 3 and has a slope of up 1 over 2. Let's see another example of this. Draw a line through -1, -2, and a slope with a slope of -3. So going back to kind of that a little bit of, I don't know if rant's the right term, but when I was talking about the importance of calling that 2 over 1, here I have a slope of -3. That doesn't really translate to this idea of rise over run. So what I'm going to do is I'm going to say, oh, -3, if I want to make that a fraction, I put that over 1. And now that I have it over 1, I say, okay, there's my rise over my run. And now I should be able to plot it with a rise of -3 and a run of 1. So again, plotting that first point at -1, -2, that's my starting point. And now again, I'm going to have my slope of down 3 over 1. So I'll pause a second, kind of make sure you have an idea maybe on while you're watching this, kind of point at where you think the next point's going to be. It's going to go down 3 over 1 from that start point, not from the origin. And so that point will be here. Now, that would be enough to draw a line, but I want to kind of bring up this, a lot of students kind of say, oh, well, what if I wanted to say the run was negative and the rise was positive? So what if I said I wanted to go back 1 and up 3? Well, let's go ahead and do that. As we see, plot that point, that is going to be on our line as well. So that's perfectly fine. Just personally for me, I say, oh, rise is negative, because that would mean down versus up, and then I'm always going to make my run to the right. That's how I keep it straight in my head. That doesn't mean it's absolutely right and your way is wrong, but that's what I do. So if you're following with a lecture, that might be how I would say it, but if you want to follow and say, oh, I want negatives to go back 1 and up 3, they're correct. You're still going to form the same line as me when all is said and done. So again, 3 points as I recommend, and then we can draw a line through those 3 points. So let's just get into this idea of actually applying this concept of slope to a real life problem. So example 5 states, for each 3 feet I fall, the wind pushes me horizontally 2 feet. If I have fallen a total of 12 feet, how far have I been pushed horizontally? Well, we mentioned that rise, as far as like a way to kind of remember it, is rise over run. So in this case, for every 3 feet I fall, the wind pushes me horizontally 2 feet. So my rise is -3, my run is 2. And then I can actually use that to set up a proportion because I know that that's my slope, but overall I fall in a total of 12 feet and I need to figure out my amount pushed horizontally. So we're actually, this is a few sections back, is we're doing this idea of proportions. So then I'm going to have -3 over 2 is equal to -12 over x. And now I can go about solving for x. I'm going to cross multiply. So then x times -3 becomes -3x, 2 times -12 becomes -24. I'm going to divide both sides by -3 because it's a one-step equation at that point. And I have x is equal to 8, but since we're actually doing an application problem, we're going to state our answer. I have been pushed horizontally 8 feet after I've fallen 12 feet. So that's a way we can kind of see that idea of slope is actually another proportion, and we've seen proportions before in this class. We can set up equations to solve proportions and solve additional problems with this concept of slope.